Okay, so let us begin today's topic, algebraic expressions. Okay, so just a second. All right. So first of all, what are algebraic expressions? Okay, let us understand. Now, if you would look here, like these are the kind of questions that you would have solved as kids. Like you had a lot of questions like this. Like for example, something minus two equals to four. What is something? Okay. So what do? Now, instead of those boxes, we replace them with a variable. Okay, get familiar with the terminologies here. We replace it with a variable. Let's call that variable x. Okay, now that variable can be any alphabet. It's not necessary it has to be x. It can be x, y, z, a, b, c, d, anything that you want. It's your variable. Okay, it can even take symbols, and it does take symbols, and we'll see when and where. But now the point is, let it be any variable. Always remember, whenever you're putting in a variable, it's a standard way to take a alphabet in lowercase. Okay, for an unknown variable, we take the alphabet in lowercase. For example, we would always be using small x, not capital X. Okay, just a standard industry procedure, nothing specific about it. Okay. Now, the reason for that would be, you would ask, like, what happens is, like, sometimes when we are doing geometry, there, when we use, like, in the previous class, we talked about perimeter and area. Okay. And before that, we talked about angles. So, there we use capital letters. Okay. So, just to avoid confusion, this is what we do. All right. So, this is what we would be doing. Okay. So, the letters, they represent the unknown quantities. We call them as what do we call them? Yes or no?
Sir, variables.
Yeah, variables. Okay. So
And
for
2 and 4 are constants.
yes, 2 and 4 would be constants because they are numbers. So we call the numbers as constants, and the part which has a variable would be the variable part. Now let's look at little more about it. So there are two differences here. Now let's understand two things. First is arithmetic. Okay. Then there is algebra. Now, what is arithmetic? What is algebra? Let's get an idea. So, arithmetic deals with numbers and different operations between them, like addition, subtraction, multiplication, division, and so on. Okay. Whereas algebra uses variables, okay, to do these operations. Okay. In algebra, we would be doing the same arithmetic operations, but not on numbers, but on variables and numbers. Okay, so it would be a combination. So you will see better once you will understand like what happens. So I've told you, like, there are two things. There is a variable, there is a constant. So now, as I've already told you, the variable can be any alphabet, X, Y, Z. Let's look at the equation that we have here. What do we see here? So we see 2x plus 4y minus 9. Now this is called as an expression. Would anyone tell me what's the meaning of an expression, or what is the difference between expression and equation?
But expression does not have an equality symbol, equal to symbol, or but the equation has an equals to symbol.
Very good. The expression is limited. It's not followed by an equality or inequality symbol. Okay? There is equality, that is equal to sign, then there is inequality as well, which can be less than, greater than, or less than, greater than, equal to signs. So here, yes, you can say that the expression does not have a right hand side because it's just one thing. Okay, so you have to remember this is an expression. Now, I want you to look at the expression and try to understand. Do you see two variables here?
Yes, sir.
X and Y, right? Now, there is one more term. Now, look at these. These are called as terms. Okay, one more terminology that I would include here is there are three terms: first, second, and third. Do you get it?
Yes, sir.
Sir, which means it's a trinomial expression.
Yes,
Yes,
sir.
that means it's a trinomial expression. That's
Sir,
perfect.
excuse me, sir.
Yes.
So just as we have for shapes, we have triangles, quadrilaterals. It's almost they're all polygons. It's similar here. Binomials, trinomials, they are all polynomials.
Yes. I'll come to polynomial part soon. Okay. It has a beautiful definition. I'll let you know. There are some complications there as well. Okay. So we'll come to it. Okay. Don't get ahead right now. So if you would look here, there are three terms in this given expression. I would call 2x as the first term, 4x as the second term, minus 9 as the third term. What is the terminology I'm using? Term. These terms together, they form what? Expression. Okay. Now, 9 is the constant, x and y are the variables. Okay. What do you say about 2 and 4 here? What are they?
So the coefficient 2x and y.
Very good. 2 is the coefficient of x, 4 is the coefficient of y. The next word
Sir,
that we use,
numerical coefficient.
coefficient. It's fine. We can just call it as coefficient. It doesn't matter. Okay. Right now, it's okay. So it's called as coefficient. Okay. When I say what is the coefficient of x, your answer should be 2.
Two,
When I say what is the coefficient of y, your answer should be 4.
four.
Okay. So understand how this functions. Get familiar with the terminology. Make your own notes if you don't already know these things. Okay. Now, so I've already explained the term part to you, right? So when there is any expression given to you, you can break it into terms and you can see which are which terms. Okay. Now, for example, for the first term, what is the variable?
So x and
Sir,
y.
x and y.
Is x and y, are x and y both variables, or you would say y is the variable, x is the variable coefficient, or something like that? What would it be?
Yes, sir. So it would be variable
No,
Sir,
coefficient.
x is
it
the literal coefficient
Excuse
of
me,
y.
sir.
yes,
Excuse me, sir.
yes.
Sir, any at any point, if it's not the last of the if it is not the last part of the term, any can be. For example, 5 can be the coefficient of x and y. One can be the coefficient of 5 x and y. 10, sorry, here. So, sir, we can say that any number taken at any point would be the coefficient of the remaining. Can we say that it like that?
I still couldn't understand your question. So, are you talking about this specific one, or are you talking about other made up examples?
Sir, like
Other made up
15
examples
y
also.
is the coefficient of
Um,
x.
Coefficient can be any number. Okay. Now,
So,
here you
like
have
5 is the coefficient of x and y.
5 is the coefficient of x and y. No, 5 is the coefficient of xy. You would consider your variable here to be xy. Okay.
And 10 is the coefficient of 5xy.
Yes. 10 is the coefficient of 5xy. No. How can 10 be a coefficient of 5xy? It would be 10 into 5. So this would become 50. Okay. Now, anyways, so there can be variables. There can be one variable. There can be two variables. There can be three variables. It all depends upon how many variables do we need. Variables basically mean unknowns. Okay. It depends upon what kind of problem you're solving. Based on that, there can be any number of unknowns. Okay. And it also depends upon your ability to take those unknowns and convert them into variables. The smarter idea would be to use as minimum variables as possible. We generally would solve equations which would have one or two or at most three variables. And whenever we have like a lot of variables, we try to convert them into just one or two variables. Okay, we'll see.